Hello, in this video I'm going to explain regarding this recurrent neural networks, and here we have given three tasks are given. One is sending this sequence of words, and next is we need to apply this grid search CV, and here third one we need to apply on different spam data. So for that we need to import all the required libraries, and in this recurrent neural networks when we take the examples, it's like a sequence of words. There is a connection between the words. We cannot predict, means each word is dependent on other word. So if you don't know the previous predicted values, so we cannot guess what it is. When we check for examples, for Google chatbot, speech sequence of words, so every word it's important for predicting the output. And sentences, like what time it is, suppose what time it is, so each time we need to send to recurrent neural network like one word like what, and it gets trained and it gives some output, and again when we send time to again next input time, so it should remember the previous word also, so it should take what place, again it should take the time. So like that each word it should be added, so that it should remember all the previous words to predict the output. Why? Because these all are dependent on each other, these are sequence of words, whereas in other models it's not possible. And for recurrent neural network we cannot send a long sequence of sentences. Why? Because it's having short-term memory, long-term memory. So if we send a long sequence, so it cannot take all the words and it remember, so it may give the different outcome. Predicted value will be different. Further, there are two other concepts like LSTM and GRU. So using this LSTM and GRU are having some gates, so that it's very good at remembering for long sequence of data. And it's better to use RNN because it uses less operations, tensor operations, and its computation is good. But the only thing is, for long sequence of data we need to go with LSTM and other thing. So here we are reading the sentiment CSV data, and we are doing some pre-processing like lowering, and we are removing all other things except these characters given here. And afterwards we are taking this particular column and we are replacing with empty spaces, and then we are applying this tokenizer, and we are converting again to sequences, all text to sequences. And next we are creating a model. In that we are taking sequential model, and we have given embedding layer. So embedding is nothing but neural networks. So afterwards we are adding this LSTM also. And this dropout and recurrent dropout is nothing but it is are used for not to come overfitting, so to avoid overfitting. And here we're adding activation softmax, it's good over here. And afterwards we're compiling it, and then we are using label encoder, we are fitting the data, and then we are using train test split, we are taking the train size as 66 percentage we are using as train size, and this 33% we are using for testing purpose. So we can give this 33% of data, and we can check whether we are getting the actual value or not by comparing with predicted value. So here we have given some batch size, and create model we are calling that function, and here we are evaluating the score and everything. And this loss and accuracy is nothing but suppose this loss is there, so this loss is nothing but it's checking the predicted value and the actual value, and it's giving how much loss it is, and here it is accuracy. And in this neural networks there is one more thing is we can use gradient descent, back propagation technique, so that it can check with the previous output, and it can adjust the weight in a small portion and to get the predictive value, to get more accuracy. So here we are importing this load model. Using this, we are reading the model. We are loading the model which we have saved here. So this one we have saved. This is the one we have saved using hy file. And after loading here, we are passing the sentence. See, this is a sequence of so many words, and we are passing this, and we are trying to predict that sequence of text, uh, positive, negative, or what kind of outcome here. So here we are taking that prediction after converting to sequences. We are passing that sequence, and we are checking with the model what type of outcome it is. So next is here we are taking grid search CV. So while predicting process, here we're taking batch size and epochs. So it gives the best accuracy, as well as for that accuracy what batch size and epochs are good. So it's giving the values here. That is grid search CV. And next one is the same thing we need to perform, but with a different data set, spam. So here's everything the same, and here just we are taking the summary. Here we can see the loss is very less. So for this data set, loss is very less. So uh, it got good result by comparing this actual output and predicted values. So they both are almost same. That's why here loss is very less. And we are printing after evaluating the score accuracy. Loss is very less and accuracy is good, 0.98 for this data set. And we are just saving it again and loading it. That's it. Thank you for watching.